There we go. So today, basically giving you kind of the overview for 3.2. What we're looking at is what do graphs of these functions look like? Okay. You'll probably have them memorized in the next month, just from working with them. Okay. Tuesday we'll come in and I actually have a little matching activity for you to do on this. It's helped people quite a bit. So basically what we're looking at is parent functions and child functions. Okay, that's what we call it, families. We're all a big family here. Yeah.
Yeah, right.
No.
They just decided.
Okay. So the nice thing about this is that if you memorize the parent functions, and I will show you how to move them left to right, up and down, stretch or shrink, and it's all the same pattern. Okay? This is in your books, so we'll just kind of give you an idea of a constant function. You notice a lot of issues with this on the quiz. If I ask you to graph y equals 0, great, yeah, it's this line right here. Because it's the y value 0 straight across. If I ask you y equals 1, y equals 2, y equals 3, those are, it's 0 slope, and this is the y-intercept. So okay. We can also do x equals 1 touches the x-axis at 1. So those are constant functions. Again, changing this number shifts it. That's all you're doing is shifting these up and down. Okay. Linear. The linear parent graph is y equals x. The slope is what? 1, because there's a 1 here. And what's the y-intercept? 0. So based on that parent graph, you can change the slope or you can change the y-intercept, right? And I'll show you to do that. Now you already know how to do linears. I'm still seeing a few issues on the quizzes, so we'll kind of get this again. But I'll show you to move these up and down, left and right. Based on
y equals x, so 45-degree angle.
yes, it is actually. Slope is 1. Think if you're going trigonometry on this, think about what shape is that?
Triangle.
What kind?
Right.
And what kind of right triangle? Isosceles right triangle. Yep. 45-degree angle. All this stuff meshes together nice and pretty. Okay, so thank you. All right. Quadratic. What's this one called?
Parabola.
Parabola. Yep. The parent is y equals x squared. Again, we will shift it left, right, up and down, etc. We'll reflect it across the x-axis. We'll do all sorts of stuff like that.
I thought y equals x squared was the straight b.
That's absolute value, which is another one we're going to hit. We can also do the cubic. Y equals x cubed, which looks like that.
So these are all parent ones.
parent functions, all parent graphs. So I'm going to show you one way that will help you move every one of these up and down, left and right, and shrink or stretch the whole. Okay. So the goal would be to have these parent graphs memorized and then how to move them, right? Let's see. We can also go to the 4th power and the 5th power, but they're just basic iterations of these. The 4th power looks like this one. It just goes up faster. The 5th power looks like this one. It's skinnier. So we just stop there for now. We can do the square root and the absolute value and a rational function as well. They are with absolute value.
So the cubic is still quadratic.
Cubic is not a quadratic, it's a cubic. Yeah.
Where's that being used?
And I'm just giving you like the most important ones. There's hundreds, but focused on square root. Yeah. Does the square root function have any negatives in its domain? No, it doesn't. So all we have is that.
Square root of x.
Oh, I see.
Yeah. Sometimes I get a little hurry when I write it gets sloppy. It's not a ray, it's actually curved. Rays are straight, that's why I say that.
But the absolute value of 2 is going to be raised.
These are rays, yes. You got it. Cube root of x, is that going to have negatives in it?
Yes.
Ah, yes. Negative 2 cubed is negative 8, right? So the odd powered exponents or roots are okay with negatives. Not one I'm going to have you memorize, but if you're interested, it looks like that. It's a light bird, right? Cube roots, exactly. So there's your cube root function. Not one I'm going to ask you to memorize, so just for your information, it does pop up in calculus here and there. More often than I would say never. And then the last one we need to really worry about is the rational function.
Rational, you're reminding of rational. Have you ever seen Grease? You've never seen Grease.
Do you remember what a rational number is?
Have you seen it? Oh, yeah.
It's a number that can be made into a fraction. Okay? Here's the parent rational function. Where is it undefined? Zero. Zero. Beautiful. So we have infinite discontinuities. That's what these are called. At 0. It never touches the 0 x values. But again, you'll have that memorized and you'll just move it and shake it. Okay? There's one in your book called the greatest integer function we're not going to mess with. It's the step function. It looks like a staircase. Back with it. So these are the ones you're going to know. You'll have them memorized. All right, now how do we move these around?
I feel my brain getting bigger. Like, we can do this.
More dense? Are you more dense now?
I hope not.
You just admitted it.
Yeah, bigger though.
Okay. No, it doesn't. You're correct. Unless it's swelling, which is bad.
Yeah. You need to go get that.
So So,
Chapman, go to check. What is this big grade?
the psychologist is down the hall. So the parent function for y equals x squared, and I'm going to get more precise here now. There's the parent function y equals x squared, right? It's a parabola. How am I going to move this thing around now?
You can move it to the left.
You can move it left?
To the right.
Which way do you want to move it, left or right?
Right.
Right. Okay, so I move to the right.
All the numbers are always there.
That's a movement to the right.
-2. So whenever you
Yeah, so there's the key. Go ahead.
So whenever you add 2, it goes to the left.
Correct. Okay, so if you pair with the x value,
Ow.
x is left to right, correct? Okay, so this is a left to right in the opposite direction. Okay, so whenever you pair with the x, it's always the opposite of what it says. So that one actually moves to the right. And it's the same graph. All we've done is translate it.
And does that work with every function, or is it just one?
No, this is every single one.
Okay.
So I can go back to my original page.
What does that mean, left to right?
Left to right. If I put +2, it's left 2 units.
So wait, that doesn't...
Because this is a -2, right?
Yeah.
Intuition would say I need to move to the negative direction. But the opposite of that is where you actually need to go. Yeah, if it was +3, it's left 3 units. Okay? Just move it. I will show you how to turn it. What? Right. Don't touch that. Don't worry about it. Just shift. That's the nice thing here. It reduces the work time.
Negative makes it go right. Positive makes it go left.
Yes. Okay.
Why do we have it?
We are using it. It's the graph shape. We just aren't messing with it. Okay. I'm giving you ways around really working with it. So, okay. How about up and down?
Can you get it back to positive?
+4. See how it's not inside with the x?
Yeah, that's
Okay,
why.
this is going to be a y translation, up and down.
Wow.
And this one is actually what it says. If it says +4, it means go up 4. That would be, if you just put a 2 in, the point is 2, 8, right? If you put a 2 in there, what's the resulting math? That's just a point on that graph. 2 over 8. You're reading way too far into this. The only time we're translating is if it's separate from the x, not if you plug into the x. Like this?
Yes, I think plus
Well, then it would be right to up 4.
This
So it's 2 shifts.
for the up and down, if you want to go down, you just change the plus sign to a subtraction.
Minus. Yep. Instead of doing it goes there. All right. Okay, now, let's say, oh, wait, I got one. We'll do this. What?
When you put the number in front of the x,
That's what you want to do?
Square.
There are a ton of possibilities here. Again, memorize the pattern. Now you can take all your functions and do the same thing with it. What if I put a number in front?
That's what I meant.
Oh.
yeah, that's what I tried to say in the first place. That's what she
Is this?
I think it would
You
just get
go
wider, right?
up 3 and out.
Doesn't make it wider. It makes it skinnier.
Oh, that's right. Let's get a number now.
This, instead of thinking about wide or skinny here, think about going up faster. So this makes it go up faster.
Which one do you do? The x quadrant?
So if it was a fraction, it would make it go up slower.
Exactly. So going up faster than the black one, right, means it's going up faster, it's skinnier. Okay. If it's a fractional number, it goes up slower. Means it's
That's when we use the rise over run. Maybe?
kind of. It's not linear, but yeah, you can think of it as in slope, it's steeper, right? Justin.
So the red equation where y equals in parentheses x minus 2 squared, that's the same equation as y equals x squared plus 4, so.
Yeah, that's right.
It's not.
How is it not? Can you simplify that one? What's that?
You're just putting the x squared in here.
Yeah.
You cannot do that. What do I do with the parentheses with a square around it? Okay. This is an excellent question. You're probably not the only one thinking it. That means that there are 2 of them. Okay. You have to FOIL. So the actual equation here is x squared minus 4x plus 4. See that? Okay. That changes things. Okay. All right. Now, the y-intercept is still 4. Okay. The y-intercept is still 4. But this middle term shifts it to the right by 2 units. Okay. So be careful when you're working that. You can't just throw the square. Good question. Okay. What else can we do with these?
That's it.
I wish it was it. What do you think?
Arthur, can't you pull them up, flip them to where they're facing the other way? So that would translate it across the y-axis.
Flex it across the x-axis.
Question. Okay, so with the green one, you put the dot at the 0 y, right?
0, 0 is still a point.
Okay.
Yeah.
And then you went up 3 and then over 1. Yes? No. No?
So, oh,
How'd
I
you
have a
graph
bunch
it?
of graph.
Well,
No.
I sketched it.
Yeah.
But that's what you would do.
So that would work for the first point in this one. And if I choose an x value of 1, right? What's my y value? 3. So from 0, 0, 0, 0 is a point as well. 1, 3. Right? What if I choose 2?
Do you read it as 3 times 2 to the square? Or do
Well,
you the square times 3?
It's 2 squared. Order of operations applies. go 2 out, I'm now 12 up. It doesn't follow the up 3 over 1 pattern. Non-linear graphs do not follow the slope pattern.
So,
Okay.
then it doesn't make sense.
It's the squared.
Yeah, it's a quadratic, so it's not just literal x. So it doesn't matter how it's drawn?
Okay. With a linear function, the slope is 3. You go up 3 over 1.
Yeah.
Up 3 over 1. That's linear. That makes it a line. Right? With a quadratic, that's because this is a first power. The quadratic, up 3 over 1.
Okay.
With this squared, the next time you put a different number in there.
So,
So
2.
1 squared is 1. The 2 squared is 4. See the acceleration there? What's 3 squared? 9. See how it's more, right? So with a linear function, it's going up to, up to, up to, at 2, 4, 6. Quadratic, it's going 1, 4, 9, 16. So it's actually going up 3, up 5, up 7.
So you just plug in the point to where, to get the other point, and then you make your graph.
Yes, that will work. Using a table to graph these still works. I'm just trying to give you some tools to kind of avoid that a little bit.
Yeah.
All right.
Now are you making it go sideways? Yeah,
Like
rotating
go more.
in a 90-degree angle.
I was gonna ask that too, so.
Not something we're going to worry about. Okay. So, if you're curious, if you want to go sideways, it's well, that's the equation.
Well, that was.
Which is the same as that. Okay, so those of you that are not lost, related to families of functions, what was the square root function? The red one? And what's the negative square root of x? So we're still using families of functions here, right? So you can still graph that. Okay, now back on track. Let's try another one. About different parent. Different family, obviously. Different parent function, same procedures to graph it. Yes, the square root function.
So which parent is this?
Square root function. See, what does that look like?
Like the curve one.
If you want to, you can put the square root function on there. Okay, what operation am I doing on this? Which movement is this? To right how many? Right 2, up 3. To the other side, so it's down. With it, across, okay. It's just following a procedure. So,
Oh, so the rules we learned with
right 2,
ground level just transfer over.
up 3, with it across the axis.
The 3 isn't underneath.
It's what?
Like,
So, here's our, okay, right 2 and up 3 would make this function, right?
yeah.
Now the negative makes it go like this, across the x-axis.
So what if you do the y, if the y was what is x, is what it was do the same thing?
I switch these,
Yes.
it would be going,
Y-axis.
it would be going this direction. No, if I switch the y's and the x's, that's called an inverse, which is what we're gonna work on in a couple weeks. It would look like this. But don't worry about that yet. Jason.
So when you flip the graph, it changes the y-intercept for, no, that's the y-intercept.
So
The up 3 and down 5. That's it.
okay, so we moved it right 2 and up 3. The negative makes it flip over the x-axis. This is 3 units away, that's 3 units away.
Okay.
It's a complete mirror image. So basically you have mirror images here. Okay. So those are the patterns that you need to have in your brains. Left, right, up, down, reflecting.
What if it's 3x minus 2 squared?
3.
So square, negative square root 3x minus 2.
Then it's just going to, it's going to be skinnier. Yes. He's going to go out faster. Oh. I have to think about it sometimes.
I know it's not linear.
These are the big 3. These ones, multiplying by a number doesn't come up as often, but it happens. Brilliant.
I know it's not linear, but you're up 3 over 2 on the purple
Up
one.
3 over 2, yeah, because of these 2 numbers.
Okay, so the negative 2, that goes positive.
Yes.
Yeah.
So if anything is attached to the x, you do the opposite. So that would be right 2, but the y values are the same, plus 3. That same pattern here. We move this one to the right 2 units because it's paired with the x. Right. There are. So if you look in your book, the ones I've done are different than in your book. Okay, so you still have example 1, 2, 3 is the step function, don't worry about it. And then if you have example 4, okay, example 5 is a word problem. I don't think I assigned, I know it is. This one?
If you send the word file,
Let's see. Okay, so basically what you're trying to do is work with the same patterns, you just have different parent functions to start with. Okay. If you need to, you can still use the table of values to graph these. So let's talk about just the basic one. If you get confused, you can still do the table of values. Okay, is that defined? No. 0 minus 2 is negative 3. Oh, these are all negative. Right. Here's this. This is where it starts. See, to the right 3 units.
wait, so
Zero.
roots, it would be like addition, whatever, inside, and then the root.
Yeah. This is all inside, so do it first. It's parentheses. No, I'm just showing you that you can use a table, but, the point here is this is how we probably used to graph this equation. But look how much easier it is if you just know the parent and you shift it to the right. Right. a.m. You're done.
So if this were inequality, like what Dave
We're gonna graph.
in this, in that.
Let's get the crap out of this.
We're gonna graph nonlinear inequalities in a week or so. So I wouldn't worry about it yet. We're getting there. But it would, all it would do is shade it here or here. We're good. Try to apply this.
Is that your nice way of saying you have homework? Yes.
I have, so Tuesday you can start on the weekend. Tuesday you have a chance to ask questions. We have an activity to do with this that'll help you out. It's not due until Wednesday, so. As always, there's probably a challenge problem in there. If you get stuck,
Always give them a shout. You hate us. I hate you.
I don't go that far with it. Strongest life. Okay, go.
Your brain is not worth an hour of wasting your life.
You have plenty of other homework too.
Yeah, I know.
But an hour on one problem.
Tell me about it, I'm gonna be loaded this week.
Just like if you spend an hour a week,
Then I'm gonna say that the rest of the weekend and then one of
If you're spending more than, like linear programming is a different animal. It'll only give you a couple of those at a time. But you might spend 10 or 15 minutes on a linear programming problem, right? But graphing these, 5 minutes, cut it off.
Now, if you
Very intense. Not that much. It shouldn't take you that long. If it does, cut it off. The only word problem on this assignment is 45.
and is that something you've gone over, or is that
It's linear programming. Again, start it, bring questions Tuesday. I'll give you 5 minutes to ask questions. Do Wednesday.